Encapsulation and decapsulation is a very critical concept for you to understand to have a better understanding of how the messages are being exchanged in a networking and telecommunications setting. We can think of message delivery mainly in these three different contexts. The first one is message delivery within a single network. And in this case, of course, to do the delivery, you have to have some sort of an addressing scheme. And we use something called physical address to specify the source and the target addresses in something called the frames being exchanged. So the physical address in this case is also called media access control address or MAC address. It's also called Ethernet address. So that's what's being used for addressing purposes within a single network. Within an internet, meaning in between these multiple networks, once you want to go outside of your own local network and go into another network, you use another type of address, which is IP address. And within a host, meaning within a single machine or device or computer, you use an addressing scheme, in this case, something called the port number. So when you receive a message from another host, the message still needs to go to an appropriate application running on your local host, because there could be so many different applications running on the same host. So there has to be a way to indicate what application the message is going to. So port number is being used for that purpose. To give you an analogy, encapsulation is like using an envelope for each of these different types of addresses. So for example, we need an envelope for port numbers. We also need an envelope for IP addresses, and we need another envelope for Ethernet addresses. So one envelope in this case is going to be inside another envelope and so on. So that type of thing is called encapsulation in this case. And then once the message arrives at its destination, the envelopes has to be opened, right? So the opening of envelopes, that process is called or referred to as decapsulation. In reality, how things work is slightly different, and to understand some details of how the things are actually working, we have to understand the message structure. So a typical network message consists of these three different parts: header, data field, and trailer. So the header is what comes first when the message is received, and the data field contains really the data to be delivered, and then the trailer is what comes after the data field. And each of these parts of the message has its own purpose. Since now you know the basic structure of these messages, it's time for us to look into how these messages are being assembled before they are sent to a target host. So this assembly process is also called encapsulation. And think of the envelope analogy we used earlier to make the process of understanding this easier. So encapsulation process begins when sending a message with the application process. So you have an application, for example, an email client, right? And the application process will generate the data to be sent. So in this case, the data is your email. And then there is another process running on your computer or host called the transport process, which will take over and then add this thing called TCP header to the data. So this is similar to the process of putting the data inside an envelope, but then in this case, the TCP header contains the addressing information related to a port, a target port, and the source port. So what port is used to send the data and what port is used to receive the data. And then the third process involved is called internet process, and in this case that process adds the IP packet header to what's given to it. So in this case that will be the combination of the data and the TCP header. On top of that, you're adding this thing called an IP header. And then there is another process called data link process, which will add frame header and in this case a trailer to the combination of three things in this case, which is the original data, TCP header, and then the IP packet header. So the frame is this big envelope that contains everything, and finally everything will be turned into an electronic signal and then sent to the network. Once you receive the message, you have to go through this decomposition process to get the actual data out of all these multiple layers of encapsulation or envelopes or headers. And this decomposition process is also called decapsulation. And decapsulation occurs as soon as you receive a message as follows. So the decapsulation in this case begins with the physical process, the physical layer process, meaning your network interface card will receive this electronic signal and then retrieve the message or turn the electronic signal into something called a frame. And then the data link layer process will take over and it will remove the frame header and the trailer. But of course the frame header and trailer have to be used first and then remove them, right? So in this case, the purpose of the frame header and trailer were to send a message within a single network when it arrives in that particular network. And then the internet process will remove the IP packet header and use that information to send a message. And then the transport process will be doing the same thing. So remember, this time we're not adding the headers, but we're simply removing the headers. And in this case, it will be removing the TCP header. And the TCP header is used in this case to identify the target application that is supposed to be receiving the data. And once you know what application is receiving the data, it is sent to the application process, the target application process, and then of course the application process will use the data for its processing. So here is a big picture view of how everything works. You start with the data, the TCP header is added to the data, and then the data and the TCP header will receive the IP header, and then finally the whole thing is encapsulated by the frame header and frame trailer, and at that point the message is ready to be sent to another host on the other side of the network. And decapsulation occurs on the receiving side when you receive the message. So you will get the whole package in terms of your message, but then you will first remove the frame header and trailer like this, and then they will remove the IP header, and then TCP header is removed, and finally you have the data, and the data is sent to the application that needs it. So the gist of what I said here is that the encapsulation and decapsulation are part of an addressing mechanism, and they're essential to send and receive messages in a network.